Hi, I'm Herb Brooks, a service engineer for Agilent Technologies, and this is Darren Decker, a GC application specialist. We're covering some of the most common issues we see chromatographers struggle with and discussing some ways to troubleshoot.
We're going to talk now about loss of resolution over time. Normal wear and tear of the column will occur as it's used. You'll lose small amounts of stationary phase over time as it bleeds out, and of course, when you trim the column to remove non-volatile contamination or damage that's occurred to the column from reactive samples. You're going to be making the column shorter and shorter, which affects the column's efficiency and affects the pressure needed to drive the correct carrier gas flow. We recommend that you log those changes into the instrument control software so that you make adjustments to your system that maintain performance and account for the difference in the column length. Method translation software can help you with these adjustments if you don't have the other software. Pay attention to the changes in velocity if your control software is not updated with the new column dimensions. So this is a good place to start when you set out to troubleshoot loss of resolution over time. But that's not the only thing that could be causing the problem.
No, it's not. It's good to break the issue down in order to solve it. Are we seeing a decrease in separation or an increase in peak width? Each of these symptoms may indicate a different core cause.
Here's an example of a decrease in separation over time. You can see by comparing the chromatograms that we're losing some of our resolution. A difference in column temperature could be causing this. I'd want to check my column temperature, make sure it's right, and if not, make an adjustment. We already talked about how the difference in column dimensions might contribute to this problem. You can verify the column phase and dimensions on the test sheet that comes with the column, and then compare that to our earlier chromatograms. As we use the column, we might be building up contamination that can actually act as new phase. If trimming the column actually improves the separation, well, that probably indicates the contamination buildup was the problem. Sometimes a bonus peak can get into our extraction or show up because of a change in our solvent. If this bonus peak decides to elute right between two peaks we had separated before, we may now have a problem. This close elution could also cause a co-elution. The only solution is to get rid of the bonus peak by tracking it down and eliminating it. Playing with temperature programming might work as well.
Now let's consider what might be causing the increase in peak width over time. Here's an example of this kind of issue. First off, you should check the carrier gas velocity. If it has changed from your original method, that could cause a change in peak width. You'll also notice a change in retention time if this is an issue. Another cause could be column contamination. Darren has talked about this before, and you need to trim your column, removing 10 to 20 centimeters or more from the front end of the column. Next, you should check your injector settings, flows, temperatures, etc. Or just reinstall the column in the inlet, especially if you just did any inlet maintenance. Chances are that something went wrong and now you have some type of flow path problem or disruption. Of course, making sure you have the same liner as in the past is a given.
You know, another thing to consider for wider peak widths is your sample concentration. Peak widths will get wider as your concentration is higher, so this is an easy place to start. And the last thing we'll discuss for this issue is improper solvent effect or lack of focusing. This should be considered if you're using splitless injection. You can lower your oven temperature, use a different solvent, or use a retention gap. You should always check for sample phase polarity match. So let's summarize this issue. If you're seeing a loss of resolution over time, one of the first things to consider is whether your column length has been significantly reduced to the point where its efficiency is significantly different. This will cause changes in your chromatograms. Evaluate your loss of resolution according to whether it's separation issue or a wider peak width. For a decrease in separation, look to the following items: a difference in column temperature, differences in column phase as well as dimensions, or a potential coelution.
For peak widening, look to a change in velocity, which could be related to a shorter column, column contamination, changes in your injector settings, a change in sample concentration, or improper solvent effect.
Well, we hope that these troubleshooting tips have been helpful. As always, if you need more help, contact Agilent Technical Support.